All right, we're going to look at standard 1.3 inverse functions. And I'm aware that this video may be a little longer, but feel free to jump to the spot in the standard that makes that you need the most assistance in. So for the standard, if we have just a function, so a function like this, so f of x equals negative 2x plus 4, then we know lots of things about it. So first, I'm going to make a table of points. Now, making this table, I know that y, I'm referring to that as f of x. And for this, if you can take a moment to fill these in and see what you know. Okay, you might want to pause the video, and we're going to go over now those different points. So negative 2 times negative 2 is positive 4, plus 4 is 8. Negative times the negative is positive again. So we get 6, we get 4, negative 2 plus 4 is 2, and then we get 0. So we have our different points here for our function, and we could label these in different ways. We could say f of negative 2 equals 8. Right? We could say f of negative 1 equals 6. We could say f of 0 equals 4. And we know that that really is talking about the ordered pair. So as an example, that is one of the ordered pairs from our table that we're given. Another thing we could do is we could graph this function. So let's see. So I'm graphing this. I made my axes a little different scales, but that's okay. I'm going to work as one of these points. And then I connect my line, right? So you're plotting your points, and let's be sure to always label this f of x. On here, I can see I've got the point 0, 4. I've got the point over here at 2, 0, just as examples for you. Now, something that we've looked at in years prior is trying to write the inverse equation for functions. So we're going to do that with a couple functions here. So write the inverse equation. So we have f of x equals negative 2x plus 4, which is what we started with working with above. And we're also going to look at this equation on the right. Now this equation should look familiar to us. It's converting Fahrenheit and Celsius. So looking at both of these, let's start with the question on the left. So how we start this is we know f of x is really consistent with y. And what I want to do is I want to do steps to get x by itself. So next, I'm going to move this 4. So I'm really solving for x. So I'm going to subtract the 4. And then I have to divide by that negative 2 on both sides. But because I'm dividing, I'm going to make a heart and split it apart. So I have, so I again have slope-intercept form. So I'm split these apart, y over negative 2. Negative divided by negative becomes a positive 4 over 2. Now I can keep going with this. I should keep simplifying it. Remember this negative I should put up front, and then I should reduce here. the next step is to switch our x and y. So in this question, we have f of x, and we want to write it as the inverse. So we want to write this as f inverse of x. So we're going to switch our x and y here. And my answer, I want to be an inverse notation. So I'm going to switch this around, and my original one was f of x, so I'm going to write f inverse of x. So the inverse, remember we write that with the -1 like an exponent, but it has to go between the f and the x. So f inverse of x is what we say, but we write it with that -1, okay? So we solved for x, we switched our variables at the end, and then we wrote it in inverse notation. Now, if we have a question like this, like Fahrenheit to Celsius, we're going to try to solve for the other variables still, just like we did before. Notice we don't have an f of x though, so we're not going to change our variables. So what can we do first? Let's subtract our 32. Next, I can do this in 2 steps. I can do this in 1 step. I have a fraction. If I want to get rid of that fraction, I can multiply by 5 and I can divide by 9. So another way we say this is we multiply by the reciprocal. And our reciprocal would be 5/9. So then the 5s will cancel and the 9s will cancel on the right side. And we get Celsius equals 5/9 Fahrenheit minus 32. Okay, so notice on this one, we're working with real variables that mean something, right? We have real variables on the first one on the left, but our x and y are pretty arbitrary, where the C and the F, they stand for Fahrenheit and Celsius. So when we were working with our f of x equals equation on the left side here, at the end, we wanted it to be written in inverse notation like this. So f inverse of x. So therefore, we had to switch our variables at the end. Now, if we're working with something as an application where we have like Fahrenheit and Celsius, we don't want to switch our variables because that would change the meaning of it all. So we're solving for the other variable, and this would actually be our inverse model of the temperature, converting temperature. So we had f by itself, and the inverse is just solving for the other variable, okay? So only when it's just a generic f of x or g of x do we switch the variables. All right, so another part that we'll do is we can take this inverse and we can try to figure out what does it mean and why do we have this inverse. So we found out that the inverse of our original function was what we wrote down here in blue, negative x over 2 plus 2. So I'm going to rewrite this. So f inverse of x is negative x over 2 plus 2. And we got that from just right below here. Now, we know how to graph this line because we see a slope and we see a y-intercept. So I'm going to write my slope is negative 1/2. My y-intercept is 2. So for this, I could plot my y-intercept at 2. And my slope, I go down 1 over 2. Down 1 over 2. Or up 1 over 2. And I can connect my points. And I'm going to write that this is f inverse of x. Now, something that I noticed is on the function, the blue function, I had the point 0, 4. Now notice on the green function, I have a point at 4, 0. Or the inverse of it. On f of x, I had a point at 2, 0. And on the inverse, I have a point at 0, 2. So what I'm noticing is that all of these values are flipped. So they're flipped. The x's and y's are reversed. So all these ordered pairs I have here, I could reverse them or I could flip them, and those would be the ordered pairs of my inverse. Also with this, we can see that it's reflecting over the line y equals x. So I know that the scales are different here, but what I did is I basically took these and I flipped them over this line y equals x, and that's what an inverse is doing. It's switching that x and y, and so it's flipping your ordered pairs over that line. Okay, so let's try and write the inverse of some other equations. Here are 2 more. You could pause for a moment and try to write the inverse of each of these. At this point, I'm going to work through these with you. So the first one, we always change the f of x or g of x to y. And then I'm going to subtract my 6. I'm trying to get x by itself. So on this one, I'll subtract 6. Some of you are more comfortable getting rid of that fraction first. On this example, you could also multiply everything by 2. That's totally fine. At this point, now I'm going to multiply everything by 2. Then, once I get x by itself, that's where I switch my variables. So I just moved this to the other side. I just flip this around and I switch my variables at the same time. And then I'm going to write it in terms of the inverse of g of x. So I'll say g inverse of x equals 2x minus 12. Okay? All right, so for the next one, we're going to find our inverse here also. So we set this equal to y. We want to get our x by itself, so we have to subtract 2 first. And then, how do we undo a cube? Well, we have to do the cubed root. So if our exponent is to the third, we'll have to do the third root of both sides. So I get the cubed root, 1 minus 2 equals x. Now I got x by itself, so I'm going to switch my x and y. And remember that the cubed root, the 3, has to be in this little crevice here. It can't be off on its own. That means something different. Then I had f of x, so I'm going to write it as the inverse of f of x, or f inverse of x, to have my answer. And there, we did 2 examples of finding the inverse. So the next part we're going to look at is looking at graphs. So the next day when we did these notes, we looked at the graph. So graph each parent function with specific points. So absolute value, we should know each of these functions from previous years. So absolute value, remember that looks like that V shape. And let's plot specific points here. So absolute value of 0 is 0, absolute value of 1 is 1, and so on. Absolute value of negative 1 is also 1. So we get that shape from our absolute value graph. Now x to the third, and we can make a little table to help us with this. And just as before, I'm going to start with -2 to +2. So -2 cubed, remember that's -2 times -2, which is 4, and then 4 times -2 is -8. So if we plot these points, I'm going to extend my graph here a little bit. Shift it up here. All right, so -2, -8, -1, -1. So I have my x to the third, which is a cubic function, and what that graph looks like, and then a square root function. Let's think about this. So we're working on the Cartesian plane for square root. We have x, we have y. And we know that our x's, we go positive in this direction, we go negative in this direction. Our y's are positive and negative. So let's make a table also for this one so we can see what it's going to look like. So normally we start with -2, -1, 0, 1, and 2 for our x values. But let's think about this. What's, if we plug in 2, what's the square root of 2? Or is that an easy number for us to figure out? If it's not, let's think about what would be an easier square to figure out. So I think, oh, an easier square would be -4 and -1 and 0 and 1 and 4. So I'm going to plug those in as my x's. All right, so the square root of -4, remember when we have the square root of a negative number, we're ending up with a complex number or an imaginary number. Well, we're graphing it on the coordinate plane or the Cartesian plane, and so we don't have imaginary numbers on this plane. So therefore, we don't have a value we can plug in or we can plot for -4. So we could say that that's undefined. Square root of -1, same thing. Square root of 0 is 0. Square root of 1 is 1. And square root of 4 is 2. So we can plot these points when it's positive. So I'm going to plot those on here. And notice how this is like a sideways parabola. And it's only part of it. So notice how, because it's positive in front, it's only the top half here. All right, so speaking of parabolas, let's take a look at one together. So inverse functions, we're still continuing on this. Let's take a look at this function. We're going to use this to kind of explore. Okay, so let's start and let's graph this function. So on this function, I know that we're in standard or we're in vertex form, but it tells me that my y-intercept is going to be -4. And then I know that the a value is +1, so I know the pattern of this parabola. And then I also want to label it. All right, so looking at this equation, can we try to figure out what the inverse would be from the equation? Well, we're going to change f of x to y, and then we're going to try to get x by itself. Good. Now at this point, we have x squared by itself. And let's recall something really quick. What if we had this question? So x squared equals 4. What do we do to both sides? We take the square root. But when we take the square root, what do we end up with? You guessed it. We end up with positive and negative 2. So positive and negative 2, right? Positive 2 squared gives me 4. Negative 2 squared also gives me 4. So remembering that the square root, taking the square root of both sides gives us that plus or minus, will help us with what we're supposed to do next. So our answer here, we have to take the square root and add the plus or minus. So now we're going to switch our x and y. And then I'll write it in inverse notation. Good. So now if I think about this inverse, I think, okay, I can plug in points. I also know that this is kind of like it's in vertex form, right? So it's inside of the grouping symbol. We could also write the square root like this. Plus or minus x plus 4 to the 1/2. So we're inside the parentheses and we have the plus 4. So that's going to move it to our vertex to the left 4. So we can plot a point there. And then I can think about, okay, if I plugged in negative 5, well, what's negative 5 plus 4? Negative 5 plus 4 is negative 1. So remember, we're not going to do the complex numbers on this graph. So let's think about if we plug in negative 3. So negative 3 plus 4 is 1. Square root of 1 is 1. But notice we'd have to have the plus or minus that. So the graph of this, if we graph the whole thing, we would end up with a parabola, but it was flipped on its side. We also could plug in 0, and we would get 2 and negative 2. So this is the entire graph of f inverse of x. Now, notice here, got a couple lines I got to draw. Notice here, so we're exploring through this. Is f inverse, is this green graph, is that a function? So remember, what makes something a function? If it passes the vertical line test. So if we have a line, this is a line segment, but if it passes the vertical line test, then it would be a function. But is f inverse a function? No, because right now we have two outputs for the same input. So because of that, then we do not have an inverse. So this inverse is invalid because it's not a function. So if the inverse is not a function, then does this parabola, the original function, does that have an inverse? No. So therefore, So if the inverse is not a function, then the original function does not have an inverse. Now, we went through a lot of steps to figure this out, and I want us to think about what we ended up with doing. So we found out that this technically does not exist. So I'm going to cross this out, but I still want to see it, just so that it can kind of help us remember our reasoning. Okay, so we do not have a function. So the green function is actually not a function. So I'm crossing those out, but I still want to be able to see it because I want it to help us figure out what can we generalize from this. So we did with the green, with what we thought was the inverse, we did the vertical line test. Now, if I'm going to do the vertical line test with the inverse, then isn't there something I could do with our original function to figure out if it's going to have an inverse? So I did a vertical function. Then let's think, how could I have figured this out before? Well, remember that our x's and y's are flipped. So if this vertical graph, if I flipped it on the line y equals x, wouldn't it become a horizontal line test? So if I look at a function and I try the horizontal line test and it fails, then I already know that I won't have an inverse. So here is that written out. So inverse functions, we're still here, still at the same standard. Determine if a function will have an inverse. And we do that by doing the horizontal line test. So we wrote this in our notes then. So determine if a function will have an inverse, you do the horizontal line test. To determine if a function or a graph is indeed a function, we do the vertical line test, but to figure out if it has an inverse, we do the horizontal line test. So looking at these, let's determine if they're going to have an inverse. So looking at all three of these, take a moment, and we're going to then go through them. So thinking about the first one, does this pass the horizontal line test? No. So it will not have an inverse. Notice for the second one here, we have a function of x squared, but we restricted the domain to only being greater than or equal to 0. This is kind of like a piecewise function that we've looked at before. Now this, we're only given half of a parabola. Does this pass the horizontal line test? Well, yes, it does. And it passes because we restricted the domain. Now, cubic function, like we started with, does this pass the horizontal line test? So will this have an inverse? Yes, it will. So yes, that will have an inverse. The middle one will have an inverse, no to the first one. And let's go through a couple more. So take a look at these. What do you think? So will they have an inverse? The first one, does it pass the horizontal line test everywhere? No, so it will not have an inverse. The absolute value looking graph, does that pass the horizontal line test everywhere? Nope. So no inverse. And then a horizontal line, it'll fail it on the whole thing. So no inverse for the last one either. A couple more for you. Let's take a look here. So a circle, would a circle pass the horizontal line test? No. But what about a square root function? So a square root function, it'll continue off into infinity. It'll continue going up and over. So this one actually will pass and will have an inverse. So let's take a look at this. This will be our last example for now. We're going to look at this and try to figure out what will the inverse be. So if I keep scrolling, So find the inverse of a square root function. We'll also graph this together too. So let's graph this one first. All right, so I noticed that the +2 is on the outside. It's not inside the grouping symbol. So that means that I'm going to shift my graph up 2. And then I notice it's a square root, and it's a positive square root, so I'm going to follow that pattern of a parabola on its side. I can also plug in values. So if I plug in 1, what's the square root of 1? 1. 1 plus 2 is 3. So I go up 1, 3. I could plug in another easy square. What's the square root of 4? Square root of 4 is 2. So 2 plus 2 is 4. So I get the point 4, 4. That's f of x. Now I can find my equation for this, and I'm also going to plot or state these points on here. So to find my inverse, remember I have y equals for f of x, so then I can solve for y, or solve for x. So what I want to do first here is move my 2. And then how do I undo a square root? Well, I'm going to square both sides. Remember that when you square both sides, that's not where you add the plus or minus. So go back to where we wrote that for the last graph, or the graph at the top of this page, to remind yourself when you do the plus or minus. So this will end up with x equals y minus 2 squared. We switch our x and y. And then we write it as inverse notation. Okay. So we write this in inverse notation, and then I'm going to switch this so that if you can see colors clearly, that you can differentiate between the graphs. So I'm going to graph f inverse of x in green. Oops, we don't want that anymore. All right, so in green, we're going to graph this. So if it's x minus 2 in the parentheses, it moves right to. And that's our vertex. But notice how this is telling us to graph an entire parabola. Well, above the square root function, that's not a full parabola on its side. It's only half of it. So what I can think about is, okay, this point is really the point 2, 0. So I switched my x and y values here. If I switch my x and y values for the next point, I would graph the point 3, 1. For the next point, I'd graph at 4, 4. And notice how it's reflected over the line y equals x. So this is the only part of the parabola that I want. So how would I tell people that I only want it in this location? Well, I can restrict the domain, kind of like in a piecewise function, how we did that. And I can say I want the parabola, but I only want it when x is greater than or equal to the number 2. So in order for this to be my entire function, I have to include, or the inverse of it, I have to include the second part here. So it would not be the correct answer if I didn't include this restriction. All right, we went through a lot there, but feel free to watch what you need. I'll see you later.